Hello, thank you for joining me today. I'm Sam Wainwright with Formlabs Dental, and in this video I'm going to show you how to prepare 3D intraoral scans, commonly referred to as raw scans, prepare them, and print those prepared models for diagnostic or appliance usage. My name is Sam Wainwright again. I'm the Dental Product Manager here at Formlabs. I've been in the dental industry for over 10 years and have been using 3D printing in dental since 2008. So a little bit of context here before we get started. So the majority of intraoral scanners, 3D intraoral scanners in the market, output raw STL files. And what that means is that the files can come out and they can have unrefined perimeters or edges, as you can see here, holes, or an assortment of other things that can be going on with them, which really are not suitable for 3D printing without using a CAD software, like a model builder or something along those lines. And so what the majority of practices, orthodontists, and even some labs are doing is that they're sending these scans out and they're having them designed and 3D printed to make models for restorations or diagnostic work like I had mentioned, or a range of uses, right? And so what some practices and orthodontists might be doing is if they need a model quickly for treatment planning or a quick thermoformed appliance like a retainer, they could be using two methods for taking impressions, still relying on physical impressions and digital impressions in other cases. And so really there's an opportunity here to make those situations even more digital focused and have a consistent workflow. And so really there's a lost opportunity with not using 3D intraoral scanning or the digital technology that you purchased in all cases. And so before today, you might be overwhelmed by the process or not know where to start, or maybe the costs are too much, or maybe you're considering going digital altogether, and a 3D intraoral scanner doesn't make complete sense to you because you want to be able to make those easy, quick models. And this is a situation where you don't have to start out with the hard things. It's just really having some basic workflows lined up before you go digital, and it's completely a valid thought or opinion. And so after today, really this will be, I think, a great first step and in going into CAD software and 3D printing and even 3D intraoral scanning to understand the workflow while being pretty simple to do and really low technical skills required. And then hopefully from there, or with this skill set and learning in the process and doing this a couple times, it'll give you a bit more confidence in taking that next step into making sort of the next 3D printed appliance, or even go even further, like designing crowns and mill them or whatever it might be, because all these workflows really are pretty similar in a lot of ways. They all have a set few steps to go from digital to acquiring data, designing that data so it can be manufactured either by 3D printing or milling, and then finishing those products. And so today, what I'm going to be going over with you today is how to use a free software, which is pretty easy to use, to quickly base and clean up 3D intraoral scans raw from the device. And then that model can be 3D printed, and those could be used again for diagnostics or quick appliances or whatever it might be. So the agenda today is a quick introduction to Formlabs Dental, the basics in getting started. I'm going to actually show you how to use this free software called Meshmixer to clean up a model, and I'm going to call this the simple model. And then I'm going to open up and try a more complex case, which has a couple more variables. And then what it looks like to actually bring that file into our preform software, which is our nesting or CAM software, and then send it to the printer to be manufactured. And then some next steps at the end, like good housekeeping. So a little bit about Formlabs Dental, and I'll make this pretty quick, is Formlabs Dental is a dental business unit within Formlabs, and really our goal and our focus here is to make the entire dental or digital dental workflow with 3D printing cohesive and logical and as simple as possible. And really, even though 3D printing is just one step of the process, we really touch on and are reliant on the front end work and after the parts actually come out and they're used. We like to have everything figured out and as turnkey as possible. And Formlabs is a almost 600-person company now. Our little dental group, I'll call it little, is over 20 and growing every month. But why I have this slide up is because even though we're only a group of 20, maybe 30 on the high end, is that we have the resources and access to 50 plus material applications engineers, scientists, hardware and software engineers, over 150 of them. And then we have a really large service and support organization, which we could tap into and use, the same systems and all the infrastructure that they can create, we can then use and learn from and grow with as well. So I think that those resources are really, really important here. And some quick stats I'll run through. In 2018, and this number is rapidly growing, but 36% of dental laboratories in America have 3D printing. Formlabs is 30% of that market share. We are the leader in the dental lab market as of 2018. And really, it's pretty incredible worldwide that customers and users of our printers have made over 200,000 biocompatible appliances like surgical guides or splints or dentures. And just general parts, dental parts and appliances, our customers and users have made over 10 million, which is a pretty astounding number. We are partnered with the industry leaders, we have software integrations, and we work very, very closely with the best and the brightest in the dental industry to make sure we're getting the best products and workflows to our customers. And recently we announced our acquisition of Spectra photopolymers a couple years ago. We made it public, and what that really does is it allows us to design, develop, test, tune, and actually manufacture standard and biocompatible resins all within the United States of America, between our headquarters at Boston and our manufacturing facility in Ohio. And we leverage our 50 plus chemists, material scientists, and everything else to help us make these products moving forward. All of our standard resins are developed by us, and we just recently released our first biocompatible material in a new standalone ISO certified facility, which is really exciting and a huge undertaking, the process involved there. So the Form 3B is the dental specific printer that we recently announced back in November as well. And it has a lot of really great workflows, and that's not really the point of this webinar or video anyway. So let's get into the 3D printing workflow overview. So again, you need to acquire data. So in this example set, you'll have a 3D intraoral scanner, maybe a CBTC scanner for bone density. If you're making a guide, you need the surface geometry as well as the bone. You then bring it into a software, dental CAD software like 3Shape Implant Studio, for example. You design and plan your guide for the best patient and aesthetic outcome. That guide then gets output from that CAD software and brought into our nesting software, our CAM software called Preform, and that sends the job, it sets up and sends the job to the printer, and it is printed, and then it gets washed, cured. You can insert the sleeve, and then you're ready to sterilize and use it for surgery. And so we're really going to be focusing on the designing stage here today. And some basics right before we get started, some context. There are really three options in dental CAD just generally. There are now CAD outsourcing centers like fullcontour.com, where you can just send your scans if you're a laboratory or practice and say you want a crown designed. They'll do it for a handful of dollars, send it back to you, and you can manufacture it. Or you can get into the sort of two premium leading dental CAD softwares on the market, full featured I'll mention, because there are others, but they're really specific in usage, is ExoCAD and 3Shape. But these are really, really powerful softwares, and they can have a really high cost, and they might not be appropriate for every use. And then lastly, free software. So there's a lot of open source or free to use software, such as Blender, which I use all the time, and Meshmixer, which I'm going to be showing you today. One other thing that I'll mention is there are more and more paid per use CAD softwares. That's not really in this bucket. I would actually put them kind of closer into outsourced CAD, but that's like like Blue Sky Bio is a good example. They have denture software and surgical CAD software. You don't have to buy their software, but you have to pay every time you make a case. So more and more options are opening up in dental CAD, but it's really great to know sort of what you're getting into before you get into buying a 3D printer or milling machine or anything to manufacture parts in the dental industry. So again, we're going to be focusing on the free option here, which is Meshmixer, which especially compared to Blender is pretty easy to use. I wouldn't really recommend Blender to any person just getting into CAD software. It's a bit overwhelming, but Meshmixer is a great first step. So you can either go to Google and search Meshmixer, one word, or here's the link here. It's just meshmixer.com/download, and it is available for Windows or Mac. Same with our Preform software as well. So you can have a complete workflow here on a Mac or a PC, and that's it. You download the software and you install it. And I'm going to go through some of the basics in Meshmixer first, and then we'll start designing a case. So let me switch over to Meshmixer. So I have the program open here, and you can see it starts out by sort of having you import or open a mesh. And what I'm going to do is I have my folder open with my two scans that I'm going to be showing you all today, the easy and the hard one, I'll call them. And I just like to drag them in. Of course, you can import and then you find it in your Windows Explorer or whatever it might be. And before we start messing around with this mesh and putting a base on it, a couple basics. So right click on the mouse and hold rotates the model. And the tricky thing with CAD software is these view controls can vary completely based on what program it is. So right click and hold to rotate the view. Another really important one is the middle mouse button or the scroll wheel, and I highly recommend using a mouse for CAD software. If you click down and hold the mouse button, it pans, and then the mouse wheel also will zoom in. Why panning is important is because say you want to get zoomed in, but you want to be more over here, then you push the middle mouse and you drag it over, and you can be more centered in the area that you're looking to be in. To go over the menus and sort of what we're going to be using today really quick before we get started. One thing first is under view, make sure orthographic view is on. What this means is it's not showing you a perspective view, it's giving you orthographic. So there's no perspective planes or anything like that. And so when you line up a mesh like this and you go molar to molar, that is actually completely straight across. There's no sort of convergence of perspective or anything like that. So make sure that's turned on. It doesn't look like reality, but you want to be able to do things accurately in CAD softwares like this. So that's it for menus. You can really pretty much, other than like save or import or open or anything else like that, there's not much else in here that I would point to. And we're really going to mainly use 3 buttons. The first is select, which selects the mesh. The second is edit, which you can use for plane cutting and a couple other things. And then analyze has one really important feature called inspector. And I'll actually use that on the case so you can see exactly what it does and how it's used. Okay, so that's the basics. So let's go back to our slides here. So I'm going to show you how to clean up and prepare the simple model that I was just open on. So we have our mesh here. Let me click to hit escape to close out our window here. So you can see that we have some ripped or unrefined edges here, but generally there are no holes. Some intraoral, or the majority of intraoral scanners, will fill holes automatically, so you'll never really have to deal with holes. But I still want to show you how to do it, because sometimes you can get them and you need to know how to fill them. Otherwise, the basing parameters, or when you extrude the base on the model, it's not going to know what to do with that hole, and you're just going to run into issues. So I'm going to make a hole. So I'm going to go to the select button over here on the left. I'm going to change the size of my brush down to maybe 10. And again, this is just to show you what to do with the hole. And let's just say there's a hole right here, right? So I'm just left clicking and dragging, and you can hit delete on the keyboard, and now we have a hole. So how would we fill that hole? So I just hit escape to close that menu. And this is especially important if you have a lot of holes, right? Analysis is really the only thing I recommend people to use this for is for hole filling. So I click on here, and very unintuitively, we're going to use Inspector. So what Inspector does is it shows to you where the holes are, and they can be in different colors based on if the surfaces don't align, or like if you see a red outline, that's generally like a bad edge or perimeter. But you can see blue is an indication of it's looking good. And you notice that this sphere is pointing to the hole I just made. So all you have to do is, to fill that hole, is click on that sphere, and it fills it automatically. And it actually does a pretty good job. You can do flat fill, smooth fill, whatever you think looks best. You can always undo things. So if you go to Actions or Undo, or Control Z, or Command Z for Macs, you can go back and do it again, or sort of see what changes. But generally, you're always going to have one hole for the overall, the perimeter of the surface, and then this hole I just added is the secondary one, and that's it. You don't want to fill this hole just yet. It's going to take too long. It's going to look really funny because it doesn't really have a great edge to fill on. It's going to be a little bit wild. So there we go. That's how you fill holes. It's pretty straightforward. And I'm going to show you two ways to prepare this simple mesh. Let's just say you didn't really care about the edge of the perimeter. You just wanted to be as fast as possible. I'll show you that first. So you go to the Select tool here on the left, click that, and we want to select the entire mesh. So what you do is you hit Control A or Command A if you're a Mac user. What that is doing is selecting all the geometry of the surface. First thing I do is I go to Modify, which is this menu right here, Smooth Boundary. So what that is going to do is going to take the unrefined edge and smooth it out a little bit. And the default settings here are really pretty good. I usually don't even mess around with it too much. And as you can see, it's done a pretty good job. You can sort of see how it's refined and smoothed it a bit. Once that's applied, you just hit Accept. And from there, all we do is go to Edit, still in Select with the entire mesh selected. That's very important. And we're going to do Extrude. And before I do anything in Extrude, I make sure to change my end type to flat. What offset will do is actually project the anatomy of the teeth down or up, so the offset of the actual mesh. But what flat does is it makes a flat bottom. So right now what it's done is it is applying a positive extrusion to the mesh. We actually want to go negative. So what you want to do in here is you can either drag this sphere here or type in an offset range. I'm actually going to go -10 just to see where I'm at. And you can always change it later. You don't have to hit Accept or anything like that. And this is actually a great example. You want to make sure the entire edge of the mesh is past the extrusion. So this is not far enough. So I'm going to change my 10 to 5, hit Enter. And again, you can use the slider with this. And then this looks pretty good. So again, end type flat, offset for this one specifically is 15. And it's a tall model, not the prettiest edge in the world, but that's it. So you hit Accept. And I'll just export this out because I am going to do a little bit in preform. So I'll bring this one in with the other two I create just to show you the differences. We're still in the Select menu, so that's why the model is orange. You can hit Clear Selection or hit the Escape key on the keyboard. And here's our model. So, and if you wanted to be as quick and dirty as possible, that's it. You just hit Export. And we go to my folder, which is, this is the folder I have for my 3D intraoral scanning demo through Meshmixer for today. And I'll name this one Quick First Model. And it comes in default at STL, but if it doesn't, you want to make sure STL binary format is the one that we're exporting it out as. And that's what Preform is going to be able to read. and it's going to export it out, and that's it. That model is now ready to bring into the 3D printing CAM software, nesting software, or Preform, and you're ready to then start it in the print. But I'm going to start that case over because I want to show everybody how, if you want to have a smoother, more refined perimeter, what to do. So actually, before I get too far ahead of myself, I'm going to drag this file in again to this project, and it's asking me to append or replace. So what that means is append will add a secondary mesh to the to this working file, but we don't want to do that. We want to replace it completely. I really don't recommend doing multiple meshes in one file. Just keep them on their own. So if you wanted to make you know, this model with a better edge, a bit of a smoother perimeter than we had, there's a couple things that you can do. You can use plane cut, or you can actually select and cut out the geometry that you don't want. So I'll actually show you both, and I'll use them both in practice here. So this is the reason why I like to set my views orthographic, like I showed earlier. I align up the occlusal plane vertically like this. So I can see the molar to molar is lining up like that. I go to Edit, here on the left, Plane Cut, and it comes in default with the plane cut, but don't pay attention too much to that. And remember, since our occlusal plane is completely vertical, I'm going to draw a line as much as I want to cut off here while keeping my occlusal plane correct, like that. And that's going to lop off a lot of the extraneous data here. And I do not want it to be filled. So before you hit go, I'm going to change my fill type to no fill. And one other trick on here is I always just like to click and drag my planes. I don't really like to use these controls. It's really laggy and sometimes hard to use. But the most important button here, if you can see it, is this big blue arrow. What that arrow does is it switches which side is being cut off or not. The transparent side is to be cut off, and the opaque, or the anatomy side now, will be left alone. So I hit accept with no fill, and now we've done a lot of the work with that plane cut. But I still want to do a little bit more refinement. I want to get these edges out and really make this look like a super nice model. So I'm going to go into the select tool, and the brush comes in like as big as this. I really don't like using a brush that big, so I usually use a brush around 15. And to be honest, I don't even really use the brush. What I do is, it's, you know, 3D CAD software is all about what view you're approaching things from. So say I want to refine or remove this edge, what I will do is I'll actually line up my mesh so I can see everything that I actually want to remove or trim up. And instead of clicking and dragging it and doing it through the brush tool, I'll actually click off of the surface, hold, and then drag. And I don't really love being so close to the tooth there, but you know, the scan data didn't give us a ton of room. But what I'm doing is I'm freehand drawing the area that I want to select. And it's really important that you make sure you end or let go of the mouse close to where you started. And there we have it. We've got the area that I want to trim up. Once it's selected in orange, hit the delete on your keyboard. And I just want to do a little bit more. You can see here that there's this little loose mesh here. So I just want to trim this up a hair. And again, I clicked off of the mesh, dragged over into it, selected everything in that little lasso, we'll call it. And maybe I'll just do one quick one here to give it a nice smooth corner. And we're going to smooth the edges like I did in the first case. But let's go around and check this out. So I don't really love that. So, oh, see, I didn't come close enough to the start of my lasso, and this is what happens. To fix that, just hit clear selection right here. And again, click off, drag. Oh, I'm out of the select menu. So select, click off the mesh, drag around to the start. It did it again. Let me try again. So let me try again here. Maybe it wasn't close enough. There we go. Perfect. So sometimes if it does something funny like that, I always try to like rotate my view, maybe start from another side or get as close as I can to that start point. So the rest of this edge looks really great from that plane cut that I did. And I'm just going to quickly clean up this area here. And again, this is why the mouse is so important, because trying to do this on like a laptop's trackpad is just really difficult. Oh, actually, I just ran into a little bit of a problem and a trick I'd like to show you anyway. If you wanted to, say you selected something like this and you want to add to this, you don't want to just delete, select, delete, select, delete. You want to just keep selecting. You hold down the Shift key and it'll actually add to it. So holding down Shift, my lasso tool again, come around, and now it's adding to your previous selection. And then again, I'll do it again. So left click, hold off the mesh, get this unrefined perimeter. Oh, see, it cut a little bit too much. The opposite can be true too. You can actually, if you want to see how to use the paintbrush, you can actually hold down Shift and paintbrush or deselect these areas. And if you can see, I can change the brush size over here on the left. And you can hold down Shift. And when you're then brushing it on, instead of selecting more with Shift held, it'll remove it. So as you can see here, I'm just painting away wonderful happy trees away on my selection. And now I've got a nice selection here, hit delete. And I think this mesh is looking really pretty good. Oh, I lost some of my rearmost molar. That's okay. It's good enough for the demo purposes, I think. And you can see, like, I consider myself pretty good at CAD, and I still make mistakes. But my number one tip in a situation like this is always review what you're doing. You know, don't commit to anything. And the undos in this program are really good. So, I could have done, 3 or 4 undos and gotten back to where that was still a part of the mesh, right? But I'm going to continue forward anyway to save time. But let's just say this is looking good. I want to smooth the perimeter or the edge of the part. So again, I need to select everything, Control or Command A to select all, modify smooth boundary, which is again under select, modify smooth boundary. I just take the default, apply, and we want to clear selection because, we want to edit because extrude is under edit while everything's selected or in orange, and then we're going to extrude. And then I'm going to do one more trick here. So just like I did before, I'm going to change the end type to flat. I'm going to go negative on offset. And I'm actually going to oversize this one. So I'm going to do negative 25. And it will make sense in a second why. Because what this offset is doing is it is sort of guessing the extrusion. And that is not necessarily the occlusal plane or the best way to set up a model, right? So what I like to do is over extrude it. And this is always better if you do clean up the perimeter of the mesh first. Once you have it overly extruded, hit accept. Then clear your selection. Clear. And go to edit. And actually, before I go to edit, line up your occlusal plane. So my occlusal plane is pretty vertical here. I have the molar to molar, edit, and use your plane cut again. But now we're going to make it to the final base. So I like to have my occlusal plane flat to the bottom of the model. So just like something like that. And I left clicked and dragged it through. It's the wrong side. So again, use the big blue arrow here to switch sides. And before I hit OK, that looks good. It looks like it's filled in the bottom. Everything looks okay. Nothing sort of funny going on. Reviewing my mesh before committing to it, accept. And that's it. Other than that sort of area that I messed up on, this is a really nice and probably most importantly, shallow model. So this is going to be the correct orientation. It's going to print a little bit quicker because it's not going to have an overly tall base. So you put in a little bit more time in CAD and you save time later because it's going to print faster, use less material, and everything else. So this is pretty much ready to go. So again, on the left side, I'm going to click the export button. And it remembered what folder I was in first, or last time I exported. And the quick first model. I'm going to do refined first model and save. And that's it. The STL goes out and we're ready to 3D print it, which I'll show you in a second. Lastly, and I'll do this one quickly, the hard scan. So this is an example. That last scan I got from a 3D intraoral scanner, and it was pretty well put together. It was a good scan. I dragged in my hard scan into the program, and again, it's asking me to append or replace. I'm going to replace it, start over with the new mesh. And you'll see exactly why I call this the hard mesh once this opens up. Once it loads, that is. Worth mentioning while this is doing this, the faster or more powerful the computer for this stuff, the better. I always recommend desktops over laptops. You just get twice the power for the same dollar. But in any case, so you can see the perimeter is blue, it's red. We've got so much extraneous data. They definitely, captured a little bit of the lip and maybe the tongue here. It's just a mess. And pretty much, if you tried to extrude this, even if it did extrude, the CAM software is going to want to try to print this and add supports. It's just going to be like a nasty model in the end. And I'm a bit of a stickler around this stuff, but the way I'd quickly clean this up is we could use the plane cut method that I showed earlier, but I'm going to do this one completely through using the select tool. So again, on our left, select. It kept my brush size, which was nice. And I'm going to look, remember, it's all about the view. So I'm going to rotate my view so I can see this lingual wall, so I can select the whole thing. So I'm going to start over here, click out of the model, and drag in. You got to be careful. You don't want to get rid of too much of the anatomy that you want to keep, right? And you also don't want to bite off too much, more than you can chew. If you try selecting too much at once, you're usually going to get, something mess up. You'll have to do it over, and then that savings and time is gone. Select select and then delete. I hit the delete key to remove. Now I'm going to line up this side. Again, left click, drag, and go right around, keeping as much as I want to. Around there, and then come right back to where I started, and perfect selection. Delete, and before I move on, you'll notice that I lopped off some of this and it's leaving this overhang here. That's okay, we just have to make sure we remove it when we come back around. So now we're ready to do, I believe this is the right side of the jaw, the mandibular arch. So left click, drag, right around here. And I'm going to go for the gusto here and go all the way to here. So really you can do this in once you get good, 4 parts, quickly loop it around. And again, holding shift, you can click and brush away if you want to keep some of that data, or don't hold shift and you can add more. Say, oh, I want that up a little bit more. You can then, that's where the brush tool is really nice. But I think the lasso tool, what I've been using, is really nice for a big overall selection. That looks good. So I need to get all the way up here, through here, to down here. So left click, drag, go around here, not get too close to the cervical margin, because this is actually a pretty good scan once you get rid of some of this, soft tissue that was moving around. Complete my circle. That looks pretty good. And importantly, I have this sort of leftover extraneous data. And now you notice that our edge is all blue, there's no more red. This is really looking pretty clean. And we're still in select, but now I need to select everything to smooth the boundary. So Control A or Command A, modify, smooth boundary. If you get professional at this, you can just hit the B key. And again, I just apply the default, usually just fine. You can go smoother if you want, but that's on you. And then we're going to extrude. And then I'm going to do a combination of the first one and the second one that I showed. So end type, change from offset to flat, and I'm going to offset this quite a bit. So because I'm going to do a plane cut. Because I took the extra time to clean up that perimeter, I may as well get a nice base that is actually in the correct occlusal plane, and it sits nice on the table. And if I'm printing this in white, for like a presentation case, I want this to be nice. And you'll notice that the extrusion is actually pretty nice and smooth since I cleaned it up. In any case, apply or accept. one more step here, which is doing my last plane cut, which trims up the base, shortens it up, and makes it relative to the occlusal plane. Again, you can either do it, I've been doing them vertically, but you can also do it horizontally. So I line up my left and right sides, through the view, orthographic view, of course, again. Edit, plane cut. It's going to apply it in some wild way, but that's okay. We're going to change it. Left click and drag. So it's pretty parallel to my occlusal plane. And it's the wrong side. Remember, it's the big blue arrow here. Just click on that once. It switches the sides. It's filled it. That looks good. If it ever doesn't fill during this step, that means you've got a funky mesh, or funky perimeter. Something, it doesn't like something. You have either a degeneracy or an inverted triangle. I would try going back and cleaning up the perimeter and re-extruding it if that happens. I've had that happen to me many times. Hit accept. I'm happy with that. Again, I was reviewing it before hitting accept. We have a small line going through it, but that's okay. One of the great things about Formlabs preform software is it has something called NetFab built into it. And if you've ever dragged in a model into the software and asks you if you would like to repair it, that's running NetFab, and it can remove degeneracies, small holes, and really fix up a lot of these things in a very, very nice way. And a lot of other nesting or CAM softwares don't have that. So I'm not even too worried about that. If there's another CAM software, I would be. Okay, so this is ready to go. This thing's looking beautiful. I'm going to export, and I'm going to do refined second model, STL. It's now exported. And now I'm going to bring up my preform software, which is loaded and ready to go. I have my folder, and remember, these are the raw scans, both mandibular scans or lowers. And these are the 3 that I just made with you all today. So I'll just drag these right into preform, just like I do into Meshmixer. I'll pop it out on me. Pop that back in. If it ever pops out on you, you just maximize the window. And it's loading the case, and it didn't have any issue with that little line. So before I do anything, I just want to show the differences between. I'll drag this one away because these are the first 2 models that I did. So this is the one that I did very quickly with the just going forward with that unrefined perimeter. And you can see it's better to look at this side because I messed that side up. You can see this is the unrefined one. It's got sort of chunkier edges and it's not as nice, and you can tell the base of the model is not really parallel to the occlusal plane. Not ideal. So I think it's worth the extra time to add in those fine features and details personally. But if you've got a lot of cases to do, just extrude and go, and just do it again. And actually, I think in this process, especially if everybody in the practice, orthodontist practice, or otherwise dental lab are involved, you'll start to learn, on the acquisition side or like scanning, you can do a lot of these sort of mesh refinements, cleaning up tongue data and all that, all chair side. It's really quick and easy to do on screen in the program, and sort of you learn and printing and doing and breaking. That's how I learn, what will work better in CAD in the end, and then 3D print. So these are our 3 models. They came in 3 different unique ways, which is always good. For these, I really recommend, so on the left side, there's this orientation button, and I only use this for one thing, which is select base. So I left click on select base, and all you do is you click on the bottom of the model, it snaps it down. And snaps it down right to the build plate. And for models like this, for speed, material usage, and everything else, I always like printing directly to build platform, as long as you can get them off the build platform well enough. And if you don't, we'll have some more content in the future about that, best practices and so forth and so on. But now you can rotate them, you can sort of nest them into each other like Tetris, and for fastest speeds, prioritize your models towards the mixer side. It is actually, it thinks this is a thing. Wow. Just goes to show you, CAD really matters. So I'm just talking to myself here. That line that I saw in Meshmixer is actually it thinks that it's a part of the geometry and it's penetrating the surface. So I'll just switch these two up. I'll just spin this one, give it enough room, nest it in there, put this one down here, and that's it. So, you can print this out of dental model, or white resin or gray resin, and you can get some beautiful models. And that's it. You would then hit print, select your panda, which I have billowy panda ready to go. You can name the job, save your preform, and I actually have the billowy panda primed, so it's prepared and ready to go. I send the job over and it will start automatically, which I love. It's a new feature they just implemented. So back to the presentation. So we did the complex case, showed you how to fill holes. Hopefully that wasn't too fast. And I also showed you preform, all in one shot. So here's just an image of our white resin, really nice for study models, diagnostic models, patient presentation cases. Really pretty material, and it's also affordable. For orthodontic use, I really like gray because we have a special setting for it. It's a really reliable resin, and it's really fantastic. And dental model is a great opaque, beigeish, great for restorative models as well. And actually, I have some that I can show you on screen. So this is dental model, really nice material, feels substantial. And this is gray, which is fantastic for fast, thermoforming, orthodontic appliances and stuff like that. And you can see this is one of my models, which I put, our logo on it, and this is sort of the next level. I even put a bevel on the model, so it prints nice and easy, and yeah, it's sort of that next level CAD stuff. And if anybody's interested in seeing that stuff, I'd be happy to share it. It's really been, for me, just trying it, printing it, breaking it, fixing it, back and forth. But I think that's, in life, that's the best way to learn, for me anyway. Okay, the next steps. We have lots of ongoing live and recorded and written education on our website, which is dental.formlabs.com. You can request the sample part. We will send you a gray model, orthodontic model, if you want to see the print quality and clarity. All you have to do is go to our website and request it, or email dentalsales@formlabs.com. And yeah, thank you so much.